We are still on completing the square, but now we look and find out what happens when we complete the square where a is greater than 1. So that's what I'm going to show you right now. So we are going to rewrite it where it still fits the form, quadratic term and linear term, and then constant term on the other side. So that's my first step. So I keep my quadratic term on the left, my linear term on the left, but I'm going to move that constant term over to the right, additive inverse, and it becomes 5. So here's where I am. That's my first step. Step 2 is I'm going to divide the equation by a because I always want my leading coefficient to be 1. That's what I want to do in completing the square. So remember, equations mean equality, so whatever you do to one term, you do to all the terms. So if this is 4, I'm going to divide everything by 4. And I get x squared plus 2x equals 5/4. Ooh, a fraction. It's okay. You can work with a fraction. So here's where I am. And now I do what I did last section. I complete my square. So I divide this by 2 and square it. 2 divided by 2 is 1. 1 squared is 1. And if I add 1 over here, I got to add 1 over here. Now, I'm going to keep this as a mixed fraction. So 5/4 plus 1 is really 9/4. So I'm going to keep that as 9/4. Okay? And now what do? I factor that. So 2 numbers will multiply together, give me 1, but add to give me 2. It's x plus 1 squared and equals 9/4. That doesn't change. And now I just square root, so that takes away there. And I'm left with x plus 1 equals, how do you find the square root of a fraction? Do you remember? We did this earlier this year. You take the square root of the numerator and the square root of the denominator. So it becomes plus or minus 3/2. So I'm going to set up 2 equations. X plus 1 equals 3/2, and x plus 1 equals negative 3/2. And so my answers here, because it's fraction, it's not irrational. It's not irrational. That's why you can't do plus or minus. These are still real numbers. So minus 1 is going to be, when I subtract 1 here, it's going to be 1/2. X equals 1/2, because minus 1 is really 2/2. So I get 1/2. And then when I subtract 1, I get, remember, common denominators, so it's negative 5/2. So when I write that in fraction form, I get negative 5/2 and 1/2. So that's how I write my answer. And again, it's in bracket form. Don't be afraid of the fraction, least to greatest. All right, so let's do some examples, some more examples together. Everything is really the same. It's just that dividing part. So if you look at number 1, quadratic term on the left, linear term on the left, take that constant term over to the right, and it becomes negative 6. Now, to get this coefficient to 1, I got to get that 2 out of there. So I'm going to divide everything by 2. That's that equality piece. And I have x squared minus 4x equals negative 3. Now it allows me to complete my square. So I divide by 2 and square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. So x plus, what did I say? Yeah, positive, sorry. I missed a step, sorry. So that's positive 4. Whatever I do to one side, I do to the right side. Now I can factor that. And that's what I get. X minus 2 squared equals 1. Take the square root. Those guys cancel out, so I'm left with x minus 2 equals positive or negative 1. So I set up my 2 equations. X minus 2 equals 1. X minus 2 equals positive 1. And so I get x equals 3, and I get x equals, oh, sorry, that's negative 1. No, I'm so sorry. Positive 2 and positive 2, so that would equal 1. And now it's in bracket form, least to greatest, so it's going to cross the x-axis at 1 and 3. All right, let me slow that down since I made a mistake on that one. And I will go back and show you let's do number 3. All right, so let's take a look at number 3. Again, quadratic term stays, linear term stays. Get rid of that constant term, so I add 34, which makes it 40. Now, I got to get rid of that 5, so I'm going to divide everything by 5. That's that equality piece. Whatever you do to one thing, you do to everything. And I get x squared plus 2x equals 8. Now, I'm going to find this constant term. So I take this, I'm going to take 2, divide it by 2, which is 1, and square it. 1 squared is 1. So I'm going to add 1 here. Whatever you do to one side, you do to the other side. That's that equality piece. Now I'm going to factor this to make it a perfect trinomial square. And 2 numbers will multiply together, give me 1. But when add, give me 2. Those numbers are x plus 1 and x plus 1. So it's x plus 1 squared equals 9. So that's this step. Now I take the square root and the square root. My square root and squared cancel out to leave me with x plus 1. And the square root of 9 is plus or minus 3. So now I set my equation. I have 2 equations. I have x plus 1 equals positive 3 and x plus 1 equals negative 3. So when I solve, I subtract 1 and I get 3 minus 1 is x equals 2. I subtract 1 and x equals negative 3 minus 1 is negative 4. It is 2 numbers, so it's going to cross the x-axis at negative 4 and 2. Okay, so I've got to have it in bracket form because it means 2 solutions. All right, so hopefully that's not much different than completing the square. We just had to add 1 extra step. That is all. Let's take a look what happens when you have irrational solutions. It's okay. It is okay to have an irrational solution. You just got to simplify that radical form. So that's all we're doing here. So let's take a look at number 7. Again, the quadratic term stays, the linear term stays. I'm getting rid of the constant term and taking it to the other side. So when I subtract 22 on both sides, I get 0 minus 22. All right, I got to get rid of this 2, so I'm going to divide everything by 2, which leaves me with x squared minus 8x equals negative 11. You'll notice I keep leaving that space. That's just to tell me not to forget to add that constant term. So I got to complete the square here. So negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. Whatever you do to one side, you do to the other side. Now I'm going to factor this. So 2 numbers will multiply together, give me 16, but when add to give me negative 8, those numbers are x minus 4 and x minus 4, or x minus 4 squared, equals negative 11 plus 16 is 5. So now I'm going to take the square root of both sides, and I get x minus 4 equals plus or minus the square root of 5. Now what's cool about this is that it's easier this way, because what happens is all I'm going to say is x equals, I'm going to add 4 to both sides, so I get 4 plus or minus the square root of 5. So it saves me a little bit of time, because this tells the reader you still have 2 solutions. You have 4 plus square roots of 5 or 4 minus square roots of 5. Either way, it's the same. So the whole goal here is that you just have to simplify your radical if it's irrational. If you have questions, let me know. Good luck.